You may or may not actually need to compile anything. Perhaps you are installing software yourself and building it, then you will need it. Or perhaps you are creating software yourself, and then also you may need to compile it. There are compilers available for Fortran 77, Fortran 90, Fortran 95, C and C++. And I think there's also Clang. So just as I showed you before, how to find the compiler tool change, you can do that, and then you can load, for instance, FOSS 2023B. And we are going to need it in a little while in order to do the simple examples, because some of those need to be compiled first. But if you want to and didn't just do it, then you can load and unload FOSS. Things to pay attention to is that there is GCC and Intel compilers, and their flags are not completely the same. And it mainly matters if you're compiling something with optimizations, or if you're, for instance, compiling an OpenMP program. Yes, also a difference in the names of the MPI compiler. But for GCC, these are the names for the MPI compilers, and this is for the regular one. It is often a good idea to use -o and some name to name the executable, because otherwise it will be named a.out as default. And if you're compiling more than one, it will be overwritten. So let's try and compile a C program that we anyway needs. So you are in the exercise folder, go into simple. And here you will find a number of different codes. Some of them will be C codes, some will be Python, most of them will be batch scripts. That is used for when we are submitting jobs to the batch system in a little while. So there are some things to play around with. The majority of these should be fixed so that they can run without anything done to them, except that you will need to compile some of the C codes in order for them to have something to run. But I'm now going to load FOSS 2023 again. There. And then I'm going to compile this program here, hello.c. So I will do GCC hello.c, and then I'm naming the output hello. You can name it what you want to, but if you want to not have to make changes to the batch scripts, then name them in the way I did, which is just the same name as the C program, just without .c. Now it's compiled. I can run it with ./hello, just says hello world. I can now also compile MPI hello C. Should be here somewhere. It's there. Let's try to do the same thing. MPI CC. And you could then run it with MPI run MPI hello. It's a short program, so it's fine, but otherwise don't run anything on the login node unless you are on Open On Demand and have your own login node to the compute node that you have allocated. Mm. It's important to run the program with the same compiler that you compiled it with. So one important flag is -f OpenMP, at least for this course, since we are compiling an OpenMP program. And then there was the -o file where you place the output, and then you can optimize it in different ways. So let's try and compile the OpenMP program. It should be here. It's here, omp_hello.c. So I'm going to say gcc -f OpenMP and omp hello. C -o omp hello. And then again, you can run it. And it's only having one thread, but you can change it. With export omp num threads equals the number of threads you want. This is an example of a environment variable. And then if I now run omp hello again, the same thing happened as before, and the reason for that is that I'm on the login node, I think. Let's see. But if you were on the compute node, it should have respected this. It actually should have it here anyway. What did I do wrong? Nothing? Yes, I didn't have an S here. Now it has 4, as you can see. So it's important that you actually spell correctly. And this is the example. And you can try rerun it, changing the thread number. It's harmless with this short code, but again, don't do it if it's something long, because it will overload the login node and make it slow for everyone. Or run it on the Open On Demand, where it's only you. If you're compiling with Intel instead, you can see the compilers are differently named, and that is the main thing here. The flags are also different. It's -q OpenMP instead of -f OpenMP, but I'm not going to do that here. In order to link with things like BLAS and other things, then an easy way of doing it is to use the build-in environment. And you do that by, after loading the compiler toolchain, you will do email build env to load it. And then you can say ml show build env, and then you will get a large number of environment variables that you can use. So here you can see here libblas. You can use that $sign in front of it, like you would do with the liblapec here. And then you can simply use that to link with instead of having those -L flexiblas -LG Fortran. So it's an easy way of linking. And the advantage is also that if we install something different, or if these commands change, then this one will not. It will stay the same. So that is an easy way of finding out how to do this in your programs. Sometimes build-env is not installed for a compiler toolchain. If it's not, just ask us to do it. And this is basically what I just showed you. I will go to